Alright, time to get ready for this test. So there's going to be some questions again on graphing these rational functions. So as we look at number 1, first of all, I would recommend that the instructions say to verify your graph by graphing on your calculator. I would start there. Get it graphed, type it in, get it graphed, and take a look at what it does so that you can have a better feel for what's going on here. As far as the vertical asymptotes go, remember that those come from looking at the denominator. Any number that causes 0 to be down there is a vertical asymptote. So because of the x minus 3 right there, then we know that 3 minus 3 would be 0. So that means we've got a vertical asymptote at x equals positive 3. There's also another one of those terms right there, x plus 7. That means negative 7 is a vertical asymptote. It turns out that it makes more sense in the next problem, but this problem does not have a hole in it because we didn't have to simplify it, we didn't cancel anything out. More on that later. The horizontal asymptote is going to need to come from the graph, but generally it turns out by looking at the graphing calculator that there appears to be a horizontal asymptote at y equals 0. So what we do is we go down to our graph and we get our vertical asymptotes graphed. So that means I put a line, or basically an imaginary line, at positive 3, which means there's something kind of going on right there, and there's also something going on over here at negative 7. So just drawing some dashed lines there. And that basically creates the basic shape of the graph. If you grab a graphing calculator now, you will see that the graph does this. I wouldn't have known what that graph looked like without using the graphing calculator, but there you go. That's what it does. Again, you can kind of see vertical asymptote, horizontal asymptote appears to be the line y equals 0. Moving on. Number 2, we need to do a little bit of simplifying on that first because we have x plus 5 on top. Can't do anything with that, but there's a difference of 2 squares on the bottom. I can factor that to be x minus 5, x plus 5, and you get these x plus 5s on top and bottom, which cancel out. That causes there to be a hole at x equals negative 5. A hole is just a sort of a blip in the graph, like a little tiny spot that doesn't exist. Now, actually I should probably finish simplifying that. So that gives me the equation 1 over x minus 5. Because of this x minus 5, that means there's a vertical asymptote at 5, because 5 minus 5 would be 0. So x equals 5 is the only vertical asymptote, which means there is a sort of vertical boundary happening at positive 5. Again, graphing it on the graphing calculator, you will see that this graph basically cruises along this line and then all of a sudden takes a dive right at that asymptote and then reappears up there and comes back down. Furthermore, technically, there's a hole at x equals negative 5, which means I'm going to go over here to negative 5, and I'm just going to put this little hole right there. From looking at the graph, forgot to mention this, and there seems to be a horizontal asymptote at y equals 0. That's what's causing this to sort of flatten out right on the x-axis. And we're done with those. Number 3 and number 4, we need to simplify and state any restrictions on the variable. So what we can do is try to factor the top and bottom. The top of that is a GCF factoring. I can divide 4 and 12 both by 4. So I factor that out. Give myself a little bit more room here. So I can 4 times x minus 3. So that's what the top of that becomes. The denominator is going to break up into be 2 parentheses. So I'm looking for what numbers multiplied make negative 15 that add to be positive 2. And it turns out those numbers are negative 3 and positive 5. And because I've got matching x minus 3's, I can cancel those out and write my final answer as simply 4 over x plus 5. Now, it says to state any restrictions on the variable. Again, that's basically the same concept as a vertical asymptote in a hole. It's just any number that causes 0 to be in the denominator. So it's just the opposite of these two numbers. And so I would basically go off to the side and I would say x is not allowed to be, so x is not equal to 3 or negative 5. Those are my restricted values. Taking a look at number 4. Same thing, it's just the factoring's a little bit different. On the top, that's a difference of two squares. I can factor that to be x minus 6 and x plus 6. And on the bottom, I can factor out a 4x, and that leaves me with x minus 6 in the parentheses. Alright, and now I can cancel some things out. I have an x minus 6 on top, an x minus 6 on bottom, and that allows me now to write my final answer as there's an x plus 6 on top, and there's a 4x on bottom. Now, as far as restricted values go, again, I'm looking for any number that would cause 0 to be in the denominator. So there's two x's down there. That means there should be two restrictions. This one's easy. That's just 6 because it's opposite of negative 6. So 6 minus 6 would be 0, so x can't be 6. This one out here is just an x kind of by itself, which means 0 is an issue. So I would say that x is not allowed to equal 0 or 6. And we're done there. Looking at number 5 and number 6. So we are multiplying. Most of you guys just think of these as kind of like canceling out problems. Now this one is already factored. That's just our way of making sure that you know the basic part about canceling stuff off. So what we're looking for is matching things on top and bottom. So for example, I have an x minus 3 on top and an x minus 3 on bottom. I have an x minus 5 on top and an x minus 5 on bottom. Now what I'm looking at is there's an x right there and there's an x right there. Those actually get to cancel out too. And what that seems to leave me with, and sometimes it just helps to kind of cancel a few things out and then just write what you've got. What I'm seeing right now is that on top I've got 2 and a 4. Those get to multiply to make 8. Oops. And then there's in parentheses, there's an x plus 2 hanging out up there. I haven't done anything with that. On bottom, I've canceled out everything but an x plus 3. And that is the end of that problem. Final answer right there. So number 6 is sort of the same version of that. It's just that we have to do all the work ourselves in factoring it. So I'm going to get my little fraction bars ready, and I'm going to factor these things. So right now I'm going to work on this top part, x squared plus 2x minus 3. That is going to factor like this. Looking for two numbers that multiply to make negative 3 that add up to positive 2, and they are positive 3 and negative 1. 3 times negative 1 is negative 3, and 3 plus negative 1 is 2. Looking at the bottom left, that's GCF factoring like this. On the upper right, that's another 2 parentheses. Looking for two numbers that multiply to make positive 10 and add to be negative 7. So that's negative 2 and negative 5. On bottom, that's a difference of two squares. So that's negative 3 and positive 3. The idea there is that negative 3 times positive 3 make -9, but then they add up to 0, which is why there's no middle number like there is right there. So it's what two numbers multiply to make -9, add up to 0. Now the fun part, we get to cancel some stuff. So I've got an x minus 2, an x minus 2, I've got an x plus 3, an x plus 3, and I think that's all we can do. So basically just writing my final answer here. On top, I have an x minus 1 and an x minus 5. I'm just going to stick those next to each other using multiplication. And I'm going to put, there's a 3 on bottom and an x minus 3. So in class, I've just described that as sort of squishing it all together. Just put this and this next to each other, and put this and this next to each other. And we're done with that page. And then I'm going to say, see part 2 video.